Yeah, I hope everyone is doing well during all this. Like Mir said, this was originally planned for container days, but I'm thrilled to have the chance to do this virtually with you. So since you're here, I hope you have some interest in infrastructure as code and continuous delivery. Most of this will focus on AWS, and there will be a bit of a tie-in with Kubernetes along the way, since I know that this group does a lot with Kubernetes. So automate your infrastructure with GitOps, Terraform, and Drone. So here I am. Very nice to meet all of you. I'm an infrastructure engineer at Meltwater, have been for over 5 years now. I live in New Hampshire in the USA with my wife, and we have 3 children. And if you want to find me, here I am on Twitter or GitHub. So if you haven't heard about Meltwater, at a high level, what we do is deliver the leading integrated media and social intelligence solution for public relations, communication, and then marketing departments. So if you're interested, our official site is meltwater.com. We have products around media monitoring, media outreach, social listening, social publishing and engagement, and social influencer management. We have over 30,000 clients around the world. These are some of the big ones you probably recognize. So the engineering organization in Meltwater is also global. So we have something like 300 engineers, something like 30 to 40 teams. There are 9 offices that I work with regularly. I think we have more that I couldn't remember, but we have offices in India, Budapest, Berlin, Gothenburg, London. I'm in Manchester, New Hampshire, Toronto, Raleigh, North Carolina, San Francisco. So we are distributed all over the place. Lots of different time zones, which kind of leads into our having to come up with processes that are well adopted without a lot of push. We really rely on putting out solutions that teams will want to use and will kind of grow and spread organically, because you can't be face-to-face and be interacting in offices very often with such a distribution. So that was engineering. I work with what is called the foundation mission within engineering. So our customers are the other engineers. We provide services, tools, best practices, documentation around lots of different things that help our engineers get their work done. So we are 2 teams, 1 mission, but 2 teams, one in North America and then another in Europe. So the North American team that I'm on, we manage like AWS consolidated billing. We manage Terraform examples and modules and best practices around that. The Pokemon logo, Death Star logo, whichever you prefer, is the drone logo if you've never seen it before, which we'll talk about a bunch. Grafana, Prometheus for metrics. So we own a bunch of these services that helps engineering teams. So and then our counterpart team in Europe manages the Kubernetes cluster. They manage things like Service Mesh, that's the Istio logo. They also run an entire logging backend that most of the organization applications send their logs. So we both, we're part of the same mission, we're part of the same goals, but we own separate tools and services that we do try to work closely together to make sure that they work seamlessly, but we have clear ownership separation. So our mission statement is we enable teams to accelerate without thinking too much about the infrastructure, allowing a rapid path from ideation to prototype to providing business value. So finally, coming around to what we're going to talk about today, GitOps. So GitOps is a buzzword, but really all we care about is that it means that Git is the source of truth for all of our running infrastructure. We don't like clicking around in consoles, launching infrastructure, and running scripts from servers manually, or following wiki documentation to actually launch things, we want everything to be infrastructure as code. So, and then that's where Terraform comes in. So that's what we've chosen as the standard, the paved road for all of our engineers. It's what we support. It's what we provide examples for. It's pretty much expected. If you are running, if the team is running an AWS account and expects to be in our consolidated billing, they need to at least, there's a certain level of Terraform they at least need to manage and processes they need to follow. But beyond that, they are able to run and use their own tools. Some teams use CloudFormation, some teams use CDK. All we really care about is that it's managed as code. And then Drone is our internal continuous integration, continuous delivery solution that we've been running in production for over 2 years now. So yeah, we're going to talk about a bunch about Drone now. Well, actually, in just a second. So more background on why we use GitOps, because we can just follow proven software development processes, because infrastructure as code is code. This is a solved problem, developing software, and we can just kind of piggyback on, stand on the shoulders of giants to do things in a seamless way to manage all this infrastructure as code. We can easily see differences over time because it's checked into Git. Pull request checks let us know what's changing and give us an audit trail to refer back to. If we're doing our pull requests well, it usually means that we can easily roll back our changes by just reverting those pull requests. And another big thing for me personally is that I feel our GitHub, we use GitHub, and that the organization is a great resource. So by just having everything in Git, I can go and search for a Terraform resource that I maybe haven't used yet. I can find, I'm likely to find, a few examples of other teams that are using that resource and reduce the time it'll take for me to learn that new thing. And then why would we use Terraform? Well, it's cloud agnostic. It's not specific to any one provider. There are dozens of providers, AWS, Datadog, Kubernetes are a few that we use. It's idempotent, so you make changes in the UI, maybe intentionally, unintentionally. Terraform is going to tell you about it, through a future plan that you execute. It will tell you. Whereas some tools like CloudFormation, in our experience, it's possible to make changes that CloudFormation won't detect, and it won't bring your system or your infrastructure back to a state where you expected it. We feel HashiCorp provides some excellent documentation, and for what you can do with it, we feel it's a fairly low learning curve and we think it's very reasonable to expect our engineers to get at least a low understanding of it. And Drone for us, it was chosen because it's container native. We'll talk a bit about runners, but Drone executes pipelines on runners. The default is Docker, so every step in your pipeline is a running Docker container that's short-lived for as long as the step runs. So, leveraging all of what Docker's capabilities give you is built right in. We're not, managing servers that have to be changed or instances where there's dependencies at the OS level that teams, we're the blocker for teams to get their changes of whatever version of software they need. They can just build whatever they need into their containers, and it's right there in their pipeline. So that kind of goes along with it being unopinionated. There's a good ecosystem of plugins. A plugin in Drone is actually just another Docker container that it expects to be run in a Drone pipeline, so it gets parameters and environment settings that it needs to do some things for you that you wouldn't have to do on your own. So like there's Terraform plugins, there's Slack plugins, there's quite a few out there that mean that you don't have to figure out what to put in a pipeline step yourself. These are of administration for us, so this is a production service for us. We felt it's been just rock solid for the over 2 years we've had it in production, and it really works for just about everything. I mean, we've seen it just really take off throughout the organization. Teams are using it for everything. They're using it for things we would never have thought of. I've seen teams, run tests that execute like 16 different containers, 4 Elasticsearch containers, 4 MySQL containers, all at the same time, doing crazy stuff we would never have thought of, and it works very well for everyone. So more information on Drone, which might be the one tool here that has the least, it's least known, I would expect. So the official site is drone.io. Drone is free for open source projects. We are enterprise customers, so we are paying for enterprise license. There is a free cloud offering, which works for public GitHub repositories, which is at cloud.drone.io. So that's a nice way to try it out, get a feel for it before you try running it on your own. So some more numbers for our internal drone service. Last I checked, we had over 1,300 repositories, and to give you an idea, we have like over 3,000 GitHub repositories. Active repositories is probably a fraction of that. I mean, so I think my guess is this is probably around more than half of active repositories are using Drone. And we have, last I checked, over 220 users. And on average, we're running about 1,000 pipelines per day. So of those 1,000 pipelines, what I'm about to share involves 28 Meltwater Terraform repositories that are following this process I'm about to share. So I checked in the past 30 days, and there were 28 different repositories that had run. And from those 28 repositories, there were 448 actual individual pipelines that ran. So this is not something that's seen just a small amount of adoption or a small amount of usage. It's very heavily in use. So now getting into what this actually looks like, this is what we would recommend for teams getting started, where, so in this case, this would be one repository with dev and prod configuration managed in that same repository. So you'd have your drone YAML in the root, and then you'd start breaking things out by dev and prod. We're in AWS, so then we break things out by region. And then we start breaking things out by project or VPC or whatever the team feels makes sense. Default is kind of for things that would be shared throughout that region, like maybe DNS zones or users for authentication, that sort of thing. So this model has been really helpful for us to keep things separate. So for example, where I mentioned our team and the team in Europe, we're both part of the same mission I had mentioned. We use the same repository for development and production between the two teams. We almost never block each other because everything is separated out by, by project or by service, and whenever one team is making a change, it's very rarely happening in the same directory as another team. So this has worked well for us in a distributed format. So let's jump into what the files beneath these structures would look like. So we would have, at minimum, like a main.tf, a terraform.tf, and a terraform.version file. So I'll talk about each of those. So the terraform.tf would define at least the backend. So hopefully everyone has maybe a basic understanding of Terraform and state files, but your state file is extremely important. You do not want your state file local. It needs to be somewhere off your machine, off of wherever it's being read and written to, and somewhere safe. So we keep it in S3, and we name our, first of all, we would set up buckets for dev and prod, separate buckets for a little extra safety. Then we would also set up the structure in the bucket to be based off of the structure in the repository. So in this example, I had dev at EUS1 default. Then that would be the dev bucket beneath the EUS1 directory, and then default.tf state. So that's an example of what our dev default directory might look like. And then, so the prod default directory might look like this. So similar idea, separate S3 bucket and same or similar directory. But this is for the VPC1 directory in this case, instead of default, but in prod. So the next file that's important is the version file. So this is how we handle multiple different versions of Terraform. So we don't want to be tied to one version of Terraform for the entire structure. That would be very difficult when we wanted to move to a newer version, where certainly like going from 0.11 to 0.12 was a big effort. It was a very hands-on process. So we would not have wanted to break everything for the amount of time it took us to update from 0.11 to 0.12. So we replace these version files in each directory, and then the pipeline I'll share in a moment will actually look for these files and then use that to download and run the version of Terraform that's in there. So that was dev and prod, and as default in prod VPC1, for example. Like we can have a completely different version of Terraform, in this case 0.11, and that's totally fine. We can move to that newer version whenever whenever our team can prioritize it. So the last file would be that main.tf. So this is just a basic example. In real life, we probably have multiple files. We don't keep everything in main.tf. You might wonder how, so there's a lot of duplication here potentially between dev and prod. How do you make sure that things are staying in sync, that you haven't diverged greatly between your dev and prod configuration files without running? I mean, we do use like diff locally on directory structures to see if what we expect is different is actually different. But a big way that we reduce that complexity is through modules. So we will go and make a separate GitHub repository for just our Terraform modules for our team. And we'll structure those in a way like here's an example directory that is its own module, and it has its own tag of example v2. So that could be dev, and then prod could be yeah, that's VPC1. And then prod could be on v1, and then the pushing whatever new version of our configuration from dev to prod can just be a one-line change of that tag, ideally. Probably not that way in practice all the time, but ideally it's a simple change like that. Very few lines involved with the change of going from one environment to the next. So that was Terraform side of it. So what would the drone side of it look like? So if you haven't seen a drone YAML file before, this is what the start of this would look like. It's kind of similar to Travis or Circle. So where I had mentioned there are multiple runners earlier, in the default is Docker. That's where the type comes in. So I'm not going to really go into other runners too much, but just know that there are other runners. You don't have to use Docker. There's an exec runner, which just runs on the OS level. There's a Kubernetes runner. I'm going to mention it a bit later. So a few important pieces of the pipeline are setting the concurrency. So we really, really, really don't want multiple Terraform runs happening in the same directory. There are ways you can prevent or you can set up locking, which would be safer. But at this level, we can make things extra safe by just setting the concurrency level to 1. So only one, if multiple commits come in from multiple people, it's going to be one pipeline that has to finish before the next starts, and so on. So the next important piece is that we only want it to trigger off of the master branch. If we're pushing up to other branches, we don't want those pipelines to trigger until we open a pull request, and then that would trigger our pull request steps. And in this case, I'm going to have some steps later on where I want to share some files generated between multiple steps. So I've set up a volume In this case, I named it .aws because there's a .aws directory that's going to have some credentials written that I want to share. So the first step in my drone pipeline looks like this. So we need to know when Terraform changes are happening, what files have changed, to then know which directories to go into and run Terraform. So not only do we need to know the files changed, we need to know if that change happened beneath the structure that has a Terraform.version file. Sometimes we remove the Terraform version file because we don't want that infrastructure brought up for whatever reason. And that ensures that until that file comes back, it won't be terraformed. So drone then gives us some helpful variables, drone commit before and drone commit after. Let us then pass that off to git-diff to know, to get the list of files that have changed. Then the sed lines that come a little after that are a bit scary looking, but they're just escaped a lot. And the end result is that we just get a list of files, or sorry, a list of directories that are changed that have Terraform.version files in them. So once we have that, now we can start going through and running Terraform. So that's the first step in our pipeline. And in this example, I'm just using the official Alpine 3 image. The other steps I'll share also look similar, where we're actually installing dependencies at the beginning. Ideally, we'd build these into an image and not install dependencies at execution time. But just so it's in the example and clear where all these pieces are coming from. So the next thing we need to do is authenticate with AWS. So this is where we feel we've come up with a pretty good solution for authentication that doesn't involve AWS access keys and secrets. So if we had our teams, setting up IAM users and hard coding AWS keys and secrets, they can be secrets in a pipeline, but those are still, potentially the keys to the kingdom. You're passing those around. They could be used for things you don't expect, malicious purposes. So what we offer teams is a way to use the instance role of our agents. Since we're in AWS, they can just utilize that instance role to obtain the authorization they need into their account. And they do that in this example through an external ID, which is kind of like a password for when you do a role assumption in AWS. And then by just using the official AWS CLI Docker image, here's where I bring the .aws volume in, set up those secrets, so like the external ID. In this case, I made the account ID and a secret also. And just with some AWS CLI commands, you can set up the credentials that are needed. And then I always like to throw in AWS STS get caller identity to prove I've actually authenticated and see that back in the log output. So the last step then would be to run Terraform. So in here, I've named my step using a drone variable. Drone supports using some variables that drone provides in the name of your step. Again, I'm using the Alpine 3 image. I'm using that volume again that was written to in the previous step. One thing I didn't mention yet is that the workspace where your code gets checked out is a shared volume by default. You don't have to do anything extra. So if you're manipulating and writing files in the workspace where your checkout has happened, you don't have to do any extra steps. Those would be available to subsequent steps in your pipeline. But in this case, because it was writing to a different directory under the roots directory .aws, I wanted to make that its own volume that got shared. So here I'm using, in the commands that actually run, a tool called tfenv. tfenv is a nice way of switching between Terraform versions. It's just actually some shell scripts. So I clone that repository and set it up in my path. Again, this would be better to have in a pre-built Docker image, but putting it all out in explicit steps here so it's clear. So once we get to that point, we can start iterating over that Terraform DIRs file that got written to in the first step. So then it's just a matter of changing into those directories and installing the version of Terraform that's defined in the Terraform version. TF-env use, then we'll use that version. Terraform init is required as the first step to download all of your modules and providers. And then if you're on a pull request, that's a drone build event variable. That becomes a Terraform plan. If you're on a push, again, that only happens on master because of that parameter we set at the beginning, then that becomes an apply. So the next thing we had to do, so that example I just shared would work well for one account. If you had one account where you were managing your dev and production infrastructure and you were only in one region, that example would probably work well for you. That's not how we actually have our configuration. So we will actually have separate accounts for like development and production. So we could build into our shell code or separate scripts the logic of figuring out what directories changed and what needs to happen. What we thought would be better would be to actually change the steps that run in Drone. So we wrote a conversion plugin. So Drone supports conversion extensions. So Drone will go out and grab your YAML, download it, and then optionally pass it off to another process that you defined. So this process for us, where that process can then do any manipulation it wants to the YAML and then pass it back to Drone. So the manipulation we do is see what files have changed in the commit range, and depending on the rules that have been set, those steps will either be included or excluded. So this then becomes really helpful in a Terraform directory structure like I've been sharing, which we'll get into in the next slide. This is this very simple example of what this conversion extension will do for you. In this here, this step would only run when README is changed. If for all other changes, it would not execute. So back to the AWS credentials example I had earlier. Now it gets a bit more complex, but this will work for detecting only changes that have happened beneath dev EUS1, and with using YAML anchors. I don't know if you haven't seen YAML anchors. They're a nice way of reducing duplication in your YAML. So I'm using them to define the block earlier, and then later on, the lower section there is what I then need to duplicate for any other directory structures and accounts and roles that I need to assume. Those can all be their own separate steps. So hopefully that makes sense. And then we would then have a similar step for Terraform, where, like most of it gets shoved up in the anchor, and then only the pieces that are specific to dev EUS1 become their own step. Briefly realized I didn't mention that some of these variables that I've had to set, AWS metadata URL, AWS SDK load config, are workarounds for a bug in the current version of the AWS Terraform provider, which when using the EC2 instance metadata for assuming the role to gain authentication, it doesn't read that correctly without those variables set. So that apparently will be fixed in version 3 of the AWS Terraform provider, so hopefully soon. How about we jump into a demo of seeing how this actually works. So I have a repo here with a very similar directory structure. So default has the similar files like I was talking about. In this case, I will share this repo after. This is all the Terraform you need on the account side to allow for that role assumption. There is some other config if you were running Drone at the Drone server side. That's the account side that you would actually use, that is being used right now for what I'm about to do. So if I go into this VPC1 directory, so here are those main.tf, terraform.tf, terraform.version files. In this case, I was in here before and I was working, and when I was done, I didn't want the infrastructure to cost me any more money. So I wanted to bring it down. You'll notice in the pipeline steps, I didn't have to create a Terraform destroy step to somehow figure out when files have been deleted to know when infrastructure should be removed. That gets very, yeah, we've never attempted to write a pipeline that supports that, because really all you need to do is remove the configuration that you want to destroy and leave behind your configurations that's managing the state. So if you do that, it's the same process of Terraform apply. Terraform apply will destroy the infrastructure for you. So here, I just have the official AWS Terraform module, or VPC module, with the example that it provides. And all I have to do is rename this file, main.tf. Or bring back to VPC1. Get that into a pull request. And watch that actually run in Drone. This is the Drone web interface. If you've never seen it before, each step, like I was sharing in the previous slides, ends up as its own step on the left here. This is the credentials step, the files change step. I figured out that I only changed WS1 VPC1, and I got credentials I need in the next step. And now we have a plan running as the final step, which shouldn't take too long. The output will, yeah, here it goes. So you can collapse, you can expand and collapse all the log output. It's really helpful and just simple and straightforward, whereas other tools I've found really try to do way too much in this view. So that's it. I got to see all my plan output, so I can verify that's exactly what I want. Back over my pull request, my check passed. So I can now merge this. And back over in Drone. Now my apply is running. So my previous job pipeline ran off of a pull request. Now I've got an actual commit to master. So you'll see, still got the same files change step, still got the same AWS credential step, but now I have a push step for a push to the master branch. So if I hit the play button and watch the output, actually watch this apply. TF init, I believe, just kicked off. Each step for it will be prepended with plus for each command, which is kind of nice. And it's applying now. So exactly what I expected. My VPC is terraformed and now it's there. So now to bring this down when I'm complete, I can just revert that pull request and destroy it. So this is the repo I was just sharing. This is private at the moment, but I will make it public shortly after the talk. So where I had said the code for the drone role assumption on the account side was in the repo. This is the important pieces of that are the policy that uses that external ID and the account where that's trusted. But again, the full example is in the repo. And then the server side of it, which is not in the repo, is really just this. So this is what we do anytime a team comes to us and says, hey, I want to use this in my pipeline. We say, okay, put this into our config, and then our agents are then, our agent instances are then able to assume roles into that account, or assume that specific role into their account. Trying to go a bit faster. So Kubernetes, I just wanted to mention some things about Kubernetes, because I know this is a Kubernetes group. So we follow a very similar process for our Kubernetes deployments, where we have dev and prod in separate directories in the same, of course, not a Terraform GitHub repository, but a separate, Kubernetes repository for our team, and where we've structured it something like this, and we'll, run things like Prometheus, Thanos, Grafana, that sort of thing. So that it works very well for us in both scenarios. And the other cool thing I wanted to share, and so if Drone looks interesting to you, and maybe you're already running a Kubernetes cluster, where I had mentioned there's multiple runners, where what I was sharing before, that whole process uses the Docker runner, which runs steps in Docker images on an instance. This new runner, the kube runner, will run steps in your pipeline as pods in your cluster. So unfortunately, this is still beta, but we've played around with it, and it looks really promising. So I wanted to mention it here in case it seemed interesting to people. And this is what the important line in a Kubernetes or in a kube runner pipeline would be. You'd set the type to Kubernetes instead of type Docker, and then your drone server would know where to send that pipeline. What else? Oh, so if you use the Kubernetes Terraform provider, then it's a very similar workflow. You wouldn't have things like the regions probably. Maybe you would, depending on how you set things up. But yeah, it could be a very similar process potentially if you're using the Terraform Kubernetes provider. Yeah, and again, if you want to find me, I'm on Twitter, I'm on GitHub, and that repo again is there up beneath my name, and I'll share that afterwards. And a couple quick extra things I wanted to mention because it could help. The team that I work in has been writing some tutorials using Katacoda. They were recently bought by O'Reilly. I don't know what their future looks like, but these tutorials are at least up there for now. They're free. We usually share these with our teams, but they could be useful to anyone. So we have tutorials on Drone if you've never used Drone, and we have a tutorial on Terraform as well. If you are interested in following what we're doing in Meltwater engineering, we have an official blog at underthehood.meltwater.com. There's lots going on there. And with that, that's the end of my talk. Thank you very much.
Thanks for having you, Jim. It was very, very interesting. I collected all the questions. I would just copy and paste them here in the chat because there were a lot of conversation ongoing. So maybe you can just have a look over it. You already mentioned that you will share the slides afterwards. Will you publish it in the Meetup event?
Yes, I can give them to you, or can I? Yeah.
Okay, so I just dropped all the questions from the beginning until the end there. So maybe you can have a look over it.
Okay, have a look in the chat. How to handle Terraform imports? We do Terraform imports sometimes, and that would be local. So we do have our own IAM authentication locally, with roles and with MFA, as secure as we can make it, where we can run Terraform locally. We try, for imports, you're importing infrastructure that's already up in your account. So it's not a matter of trying to apply something really locally and bring up infrastructure. It's something that's already there. So we would, so we would go into the necessary structure and run the import there, and which would then get it into our state file, and then we'd have to write the Terraform that's associated with it, and then that would go up into a pull request and likely be a no-op note. Your infrastructure is up to date, you'd see, because it wouldn't actually be changing anything. And how do you rename and move resources? TF state move, I have never used. So I don't know. I will look into that. Move and rename resources. Normally, if I've never seen that command, so I will look into it. But if our normal process would usually be bringing up new infrastructure and moving things over to it. Hopefully it's something we have a load balancer in front of, and we can start sending traffic to it, and then tear down the old infrastructure. But if there's ways to somehow move like if names, I'm assuming, I'm going to make some assumptions of what that command does. Maybe it lets you rename your infrastructure in ways that would normally result in a destructive process. So that sounds really interesting. To look into that. More questions coming in.
Yeah, more questions coming in, and
Yeah.
still a lot of questions are not answered. Great. So yeah, just feel free to answer a few more questions, and if you have still open questions, you can always ping Jim on Twitter or whatever and ask him all your questions you have, or that's fine, or not, Jim?
That's fine. Absolutely. Yeah. So Istio, I'm not sure how they're handling it. I know that they use COPS to manage the cluster. So I'm assuming and I know they don't use the Terraform provider. I believe right now we are the only team that's been playing around with and actually using the Terraform provider for Kubernetes. I know they're doing everything in YAML. Although we have other teams using Helm. Yeah, a lot of people love Helm. And as long as Docker is not involved, build container, ease build automation. Unfortunately, it's possible. The container should not run within orchestrating. I think there's a comment from Luigi around building containers probably within Kubernetes, and I think that's a valid concern. At the moment, I mean, I know there's projects for building Docker images without having access to the Docker socket. Something I didn't mention in the talk is trusted repos. So we trust our engineers. We trust, if you're in our GitHub organization, if you have a private repository in Meltwater, that we will actually automatically trust your repository, so it's allowed to use the Docker socket. That's the way we get around it, is that we have a level of trust expectation, and yeah, teams can then build their own. They have full access to the Docker socket. But yeah, in Kubernetes, that would be another challenge. How do you deploy? Manuel says, how do you deploy an application into this generated arch using the Helm provider, TF or something else? Not sure if I understand that question. How do you deploy an application? Sorry, Manuel's question, I don't quite understand. This question, is Drone open source? Yes, I believe there are some components that are not, which are only available in the enterprise version, but yeah, it is open. It is free for open source projects to run on their own. And Werner says, if you are not in a multi-stage environment, would Drone help or be overhead compared to other CI solutions like Travis? For not multi-stage. So, I mean, there's no reason, if you're not in multi-stage, no reason to have multiple stages. There was a time in Meltwater where before we ran Drone, teams ran either their own Jenkins or they used Travis or Circle, and things were really spread out. And there were a lot of there was a lot that teams still wanted out of a CI/CD solution that they weren't getting. So Drone really, like I was saying, just took off once we first offered it very organically. So TravisCI specifically, like we had a lot of teams move off of TravisCI very quickly because they had a much better experience in Drone. So I don't see it that yeah, any additional overhead would be significant. How do you handle apply failures? Ooh, that's a good one that I forgot to mention. So apply failures for us, for our team, we've decided that if you merge the master branch and apply fails, you get alerted. You actually get paged because that's very important to us that our master branch actually reflects what's really running. So as soon as an apply fails, that's not true anymore. And then we kind of, that person is expected to drop everything and fix it. So apply failures, you know, first of all, you get alerted and then you start fixing it. And then hopefully through the same kind of process, if for whatever reason there was like a permissions thing or a race condition or something that didn't actually need a change pushed, you can hit the restart on the job that failed and it will rerun at the same commit revision. I'm not sure how much more time we have, but I'm totally happy answering more questions.
Sure. I mean, there's no rush from my side as well.
Okay.
I just asked the people to ask any questions if they still open again, because I think now scrolling up all the time, it's a bit difficult. So
I'm catching the ones that I see at the time I look.
Okay.
So,
okay, they're coming now a lot more. So
yeah.
Feel free.
I like this big block from Jeffrey.
Yeah.
So the slide deck, yeah, slides will be shared. Why Drone and not Jenkins? I briefly just mentioned Jenkins and not AWS. So we've used Code Pipeline. Code Pipeline was fine. Code Pipeline worked really well. And actually, we had a solution that was specific to Terraform in Code Pipeline that we provided as a CloudFormation template. Like for people that didn't have any Terraform yet, like here, run this CloudFormation template. It'll set up a Code Pipeline for you, and then you can start running your Terraform. The idea was it was going to be a low barrier to entry to running things under CI. So that worked fine but the visibility was only for the team that could get into Code Pipeline. So we don't have, there is no expectation in Meltwater that if you're on one team that you can view another team's account. So if a team had a Code Pipeline in one of their accounts, it's basically invisible to any other team. They would have to, set up access manually to let that other user in to see that Code Pipeline, where Drone is available to everyone in our GitHub organization. So that was the big thing about not using Code Pipeline. Jenkins, we ran Jenkins for a long time. There are still teams running Jenkins for certain things. We actually just had a meeting with one of our biggest teams around how they use their Jenkins. They would like to move to Drone, but they've written so many customizations that it's not practical at the moment. But they would like to not have the overhead of running their own Jenkins. So the big issue for us with Jenkins was that teams are always, and maybe this has changed, things are always changing in the Jenkins world. But at the time, we would run an agent somewhere, and if some new dependency was needed, so Docker was not involved. Maybe there's ways to make Docker more integrated into Jenkins these days, but you could not easily run a step in Docker. So it would be a matter of, oh, I have this new dependency that I need for my team on this agent. Can you please install it? Or that the dependency you installed for that other team broke my stuff. Why'd you do that? It was just a constant nightmare of trying to manage that. And then the actual configurations themselves lived in one place. Like I did use the Jenkins DSL at one time to generate jobs, and that worked okay. But I mean, it's such a better experience for our engineers to have a drone YAML in the root of their repository, just like Travis and Circle support, which is, you know, it puts everything in their hands. They don't have to, we're not a blocker. They don't have to come to us for changes to what their workflow needs. And I'm gonna have to skip questions. There's just so many. How do you handle module call deletions? It means Terraform destroy explicitly. That hasn't been my experience. If I have a module defined in a .tf file, if I just rename or remove that TF file, that module and everything that was managed beneath it gets destroyed. So maybe there's another, or maybe I'm missing something, but how do you prevent, from Siegfried, how do you prevent Team A to use AWS account from Team B? The easy answer is they have no access to accounts for other teams. And they have full access actually for how they set up their IAM users and who they allow into their account. So we give our teams a lot of autonomy, and it's a lot of, you know, at times challenging for teams with less experience in the cloud, which is where we come in. We work with teams a lot to get their comfort level up so that they're comfortable with all the process that they need to run their infrastructure. Now there's just some good discussion going on.
Yes, your talk is very good. So
I'm thrilled. Great. Thanks, guys. Thank you, everyone. How do you do dev test branches? Oh, that's a good question. Branches. So we have another so what I shared was a single branch. And so that's our default we go with. We say, hey, you're just getting started, we recommend this. But we also say, hey, you can do this in a branching model where you have like a development branch, maybe a staging branch, and then production. We have followed that before, and we have some teams following that now. We abandoned it because it effectively became a one-lane road. Once you got a change into development that wasn't ready for the next level, then you were a blocker to anyone else who wanted to get something off to the next branch. Unless you tried to then go in and do some cherry picking of commits, which was just not a fun experience ever. So yeah, that was actually back in the time where we were doing a lot of work together with the European team, and we were just constantly annoying each other with changes that weren't ready to go off to the next step. So you absolutely can do it. Branching works. There's no reason not to, other than as long as you're managing that one lane road well, it can work fine. What we've seen is it works pretty well for certain projects, like this Terraform Terraform repository manages this specific project, no other projects, then it works pretty well. Anything else? Anything else? Cross-region resources is another great question. The directory structure I shared at first did have like EUS 1 and US East 1 as examples, I think. So at the moment we don't do very much cross-region, so I don't have much for examples. But the idea would be that you would have similar structures between, because AWS treats their regions as independently, so we would want to keep our code independent also, which once we start doing that more might become more painful, where I need to get a change out, and it means I need to change 4 directories structures or something where each directory is for a different region. Like that might get old fast. So we make come up with other ways to do that where we were doing sim lengths or modules or something whereby changing one would mean it would automatically change others. So someone asked, why not just have several region-specific providers in the same module? That's probably fine. Yeah, that could be a solution to work around. If we felt that was painful, that could be a potential solution. Just build everything into a module. Can't think of anything horrible about that at the moment, but could work. How do you manage cross-state dependencies? We do like outputs in our state files that then become dependencies of other infrastructure. And maybe, you know what, I bet you're asking, maybe you're asking if you change multiple directories, which this model does support. You can go into like dev and prod. Hopefully you're not doing that. Hopefully you're doing dev first and then prod separately. You could change multiple directories, and you would be right that there is no precedence at the moment. We don't have a good workflow for, oh, I need to change multiple directories, and they need to be applied in this order. Other than if you had named the directories, alphabetically or something, then they would effectively go in order. But yeah, that would be a good improvement to have. Yeah, well, we're over an hour.
Great, thanks so much again. Yeah, I think this talk was very, very interesting for all of them. So,
okay.
Yeah, as I already mentioned, we will publish a recording and share the slides with all of you. So, yeah, if you have any further questions, just you have to ping Jim separately or privately. You have then his contact details. So yeah, thanks everyone for joining. Thanks Jim for presenting and sharing your knowledge. So that's actually from our side then. And yeah, I wish some of you a good night. For you, Jim, good night. For some of the rest, have a good day. So it's ours very interesting from what time zone the people are actually joining. Yeah, so have a good one. Thank you very much, everyone.
Great. Thank you, everyone. Hopefully see you in person sometime.
Bye-bye.
Thanks. Bye-bye.
Bye.